Hello.
So, technical note before we start, I thought that we're supposed to have lighting here. Ken, is there a chance we can have lighting?
Plenty of light coming off the screen.
That's right. Indirect.
Um, yeah.
This is very difficult to do in real time, you know.
Or computer vision.
So I guess I think that like one question before we start. How dare you? Like, is it something I did that you're leaving us?
There's lots of people leaving.
No, because it's
Pete Shirley, March 6th, he retired too. So hey, we're not alone.
It's a trend. Yeah.
Yeah, and like Michael Abrash as well.
Right.
But so I think the best way to frame the story is just like when Naty joined the industry, you had been working in graphics for about 12, 13 years at that point. You started in 1983, I would say.
Yep.
Yeah. So what was the what were the prevailing assumptions in computer graphics back then? Like,
Yeah, assumption. Well, radiosity was clearly going to take over the world because I'm from Cornell. So,
While it did.
well, there you go. Indirectly. But yeah, no, right. What are the assumptions? I don't know. It's ray tracing and radiosity were definitely, the hot things. And I mean, yeah, my career path was basically 83 to 85. I went to Cornell. I like back in the day, I do my quick story, which is just back in the day, there weren't these there wasn't email basically. There wasn't, the internet or anything like that. And so I mailed my I the way I got interested in graphics was seeing the back cover of a 1982 Proceedings with Rob Cook's little Hershey Kisses, the pretty little Hershey Kisses. And I went, that looks really cool. I remember sitting in a crummy apartment in Harvard Square in Al Barr's apartment, who lived like a monk. He had a bed, a chair, and a table, and what else would you need in life? And yeah, anyway, just seeing that was just like this striking moment of like, oh, that is so cool. Like just these little Hershey kisses of materials, like, oh, that looks like copper. Whoa, that's cool. So that's all it took for me. And in fact, actually, I'm going to break in right now and I'm going to ask, okay, show of hands. Um, who got inspired by? I mean, who got really like? We all like graphics in some way. That's why we're here. Got inspired by seeing like a film where it's like, oh, I want to do that. I want, I saw a film. I want to go do that kind of thing. They're making these cool graphics effects. Okay, so we got some people. Raise them high. Okay, this is cool. Yeah, no, I like this. Um, Next, how about video games? Like you got inspired by video games, right? Right, Natty? So how about, lots of video game players out there.
It was mostly that Byte article.
Yeah, that Byte article. Yeah. And so that's the third one, though, is still images.
Yeah.
Yeah. So what about just still images? For me, yeah, still image.
Yeah.
So we're old. He's old. But anyway, yeah. So yeah, I mean, certainly films and games, I think, were the main thing. I don't know. There's also none of the above. And did anyone not get any of those, or we'll talk to you later. Oh, we'll talk to Nelson. Boy, I want to talk to you later about what inspired you. But yeah, I don't know if you realize Nelson's still working away there.
I wasn't expecting to see you in the audience. Thanks, Nelson. Your technique was very useful.
Right. Well, we'll ask you later about what your opinions are on the Schlick approximation, because he had a poster about that. So anyway, where was I? Oh yeah, so Cornell. Yeah, we were obviously into radiosity, ray tracing, and yeah, physically based was kind of a thing, but and yeah, taking these measurements and so on, but it wasn't really much of a thing at that point of like really doing sort of serious. I mean, there was like Ken Torrance and people were looking at, microfacets and all these kind of things. They were sort of in the mix, but that whole physical measurement kind of thing hadn't really occurred. And you have much better sense, I think, of when sort of people started really being serious about BRAFs and all that stuff.
Well, I mean, it depends if you're talking about industry or academia, because academia, I mean, Jim Blinn published basically all of microfacet theory plus or minus in 1974. So, so the academia had been interested in this stuff for a while, But as far as industry, both game and film, as we saw it, it took a while. The one outlier I was able to find was Blue Sky Studios, that apparently was using it as early as 1990. But they were like almost 2 decades before pretty much anyone else in either industry. So I think on the game industry side, we just couldn't afford anything. And I'm not sure. And on the film industry side, like I said, I think there was a lack of urgency. They had the flops maybe sooner than we did, but there's lack of urgency because they could just kind of shot tweak things around to look good. Now, there's a lot of benefit of not having the shot tweak, which is why physically based shading took over the film industry eventually. But it wasn't as existential, I think, for them as it was for games.
Yeah, it's interesting. I hadn't really realized that they were almost parallel or nearly arose at the same time because I sort of my from the outside view was like, oh, like yeah, the big boys, the film
That was
guys.
my assumption. Like,
Yeah.
it's like I need to start these stuff. It's like, oh, look at what movies are doing. Surely they have it all tied up for
Right.
had it all tied up for 10 years at this point, right?
Yeah, no, it's funny that, and yeah, it makes sense that for games you like are like, well, I just, I need to get a consistent answer and I can't tweak.
Yeah, and
So
you
yeah.
don't know what the camera is, you don't know what the lighting is.
Right, right,
And,
right.
and there is something to be said here about the fact that you're joining, like you joined the industry basically with some assumptions already fixed in, and for you they were changing in real time. You like by the time uh by the time you started working in 3DI, like Pixar had become a thing, had become a startup. And they were working with assumptions that you didn't have at the beginning of your journey. I I'm just wondering, there was a point where you decided this is worth telling other people. It's worth keeping the state of the art of the industry. Like it's worth for you keeping tabs of the state of the art of the industry. And you've done that multiple times, right? You've done that once, like having a news group for yeah, and I'm not that old, but I'll try. Having a news group for ray tracing news.
Right.
And then 9 years later, you decide that it's time to put this knowledge to the public because someone is wrong on the internet. So yeah, just if I may intervene, tell me how that started.
Yeah, no, it's that yeah, weird kind of luck thing. I mean, I'm trying to go, yeah, how did that happen? Like for me, my first publication was or not publication, but sort of outreach to whatever, was I had written up a bunch of things about, oh, here's how to do basic ray tracing, like here's how to ray with the sphere, ray with the triangle. And somehow Andrew Glassner ran across that and he said, oh, I'm having this course about ray tracing at SIGGRAPH. Why don't you talk about those two things? That could be your part of the course. And, you'll be with, Paul Heckbert and Pat Hanrahan and Jim Marvel and these other guys. And I'm like, well, okay, sure. And amazingly, the audience didn't totally fall asleep because I'm thinking back on it, like, I showed equations, which is like the cardinal rule of like, yeah, you don't want to do too many equations in your talk. But anyway, that turned into a book, Introduction to Ray Tracing. And yeah, and it was just suddenly like, well, of course you share information. I got a lot of that honestly from Andrew, where if you think I share information, wait till you see Andrew. I mean, honestly, he's teaching like 3 courses at SIGGRAPH this year. It's like, oh my gosh, the guy's a dynamo. I mean, so he's just, this constant font of like, well, look at this new subject. Oh, let's learn about quantum, computing. Let's learn about AI. So, anyways, it's super inspirational. I mean, he really did start a lot of things like this ray tracing, ray tracing news group and stuff like that. So, anyway, that just got me hooked on it. It's like, oh wow, there's this community, share these ideas. It's exciting.
But it took so between then and when you started writing the book, which would be you started writing it in about 96 or so.
Yeah,
The book we're talking about is the first version of real-time rendering, which it is the book. If you look it up on Amazon, by the way, the first edition has the cover upside down. Really, and you can get it for $6. Um, so yeah, what led to actually needing to publish this, and how did you get to Thomas Muller to do that?
Yeah, no, it's really funny actually. Like, so I had been, okay, so we had introduction to ray tracing, and then like I say Andrew Glassner, he started graphics gems, and I got involved in that, and I almost edited one edition, and then I had a child. And that said, well, I had to choose, and it's like child. Okay. Um, and but yeah, but nonetheless, anyway, graphics gems, and that led to sort of journal graphics tools and getting involved with AK Peters, Allison Klaus Peters, publisher. Wonderful games and robotics and all those kind of, I mean, not games, but math and all kinds of other stuff that they published. And so I was just reviewing stuff for them. Like, they would get proposals for books and I'd be like, oh, let me look at it. And so this guy, Thomas Muller, uh, had his book proposal, and I'm like, oh, this is really cool. Like, ask him if he wants help. And and what particularly got me about that book is the fact that Thomas Muller started this book while he was in the hospital recovering from something. And he was in the hospital for a while, I think like maybe a month or something. Me, I would be like watching bad TV, reading some sci-fi crap. He's like, oh, well, you write a book. And so he started this book and it was fantastic. And I'm like, oh, how do I get involved? And so anyway, not to go on and on about it, but it's pretty amusing. We both like started to just, write it basically, and got so and so far, and said, okay, that's a book. And this is like, in the ancient days, in the, days of, I don't know, Morse code or something. Basically, we emailed each other, and it actually worked out really well with time zones because he's in Sweden, I'm in, the East Coast or whatever, and we're just, he does his shift, and then I take my shift, and so on. If we just got a third collaborator to Japan, it would have been, 50% longer book. But anyway, and we never ever talked to each other. We had never met each other, and we never even talked to each other until the first draft was done. We actually spent the dollar a minute. Back in the old days, you had a dollar a minute for a phone call, and we talked for like a whole 5 minutes or something. So anyway, it's just a different world. So that's my long version.
So just it takes what 7 years between that and Naty joining for the third edition. Tell me a little bit about like how the industry took in this knowledge. Like who did this help?
Oh yeah, yeah. It came actually at a very opportune time in that like graphics accelerators had come out, right? We have 3D effects, we have, 20 competitors. I mean, I wanted to ask you about that of like what kind of, other than PlayStation, what other, sort of on the PC side, whether you had to program any of that kind of stuff.
Okay.
So let's bring it. I've talked too much. Go ahead.
Oh, you're asking about, I was talking about how in the 1990s, just getting a texture mesh on screen was an accomplishment. And, they didn't call them GPUs yet. I think Jensen coined that
Right.
term about a decade later. But well, first of all, there were 2D Windows accelerators, right? These were cards you would put in your PC to make Windows run faster because it would do 2D blitting. And eventually, companies started developing 3D accelerators as well. The first few typically needed to be separate from the 2D cards. You need to have a 2D card and a 3D card. Um, a lot of them were really bad. We used to call them graphics decelerators. It was actually faster to run a software rasterizer.
Yeah, yeah.
And there was the 3DFX Voodoo was really good, but it had its own API and it was expensive, but it was awesome. I remember the first time I ever saw GL-Quake. So I had run Quake, regular software Quake before, and it had, the textures, if you zoom in, they're pixelated, and the particles are all squares. And then I learned about this thing called GL-Quake, and I had an opportunity to look at a computer with a 3DFX Voodoo that running GL-Quake, and I was like, all the textures have bilinear interpolation, and the particles are round. And I was like, holy shit, this is amazing.
Yep.
It was like such a huge jump.
Yeah, yeah, yeah. No, I agree. It was one of those, yeah, seeing that, like, I think I may have seen SIGGRAPH Floor or something or other, but it was just like, oh my gosh, and also it was like, I'd been working on, these, like you talked about $30,000 workstations, HP or SGI or Apollo. Did you ever work on any of those kind of workstations?
No, never.
Wow, you missed that era. That's, yeah, no, financially, like, you're like, I mean, I sort of saw, like, yeah, these cards coming in, and I'm like, that industry is doomed.
I did skip over. I initially had a slide for my very first machine that I programmed on. It was a Commodore PET, but I ended up taking it out for brevity.
So I have a question just for that time frame. I think this is interesting, just to Naty's point of like the need to educate. So GPUs came out. and people needed to use the one of the 30 APIs to write graphics. Were the dev techs teaching the right things before the book? Like, did you have good techniques? Was lighting even like something to take inspiration from in the fixed function pipeline days?
Yeah.
Where did you come up with the ideas? Is what how I'll ask this.
Well, yeah, I mean, if you're asking about game industry, so talking to graphics hardware representatives or the DevRel was always a bit of a frustrating thing, because the thing is that the moment that we want to start implementing their stuff is when everyone else has it. That is the exact moment at which they don't care if we implement their stuff or not. They want us to implement their stuff when only they have it.
Right.
And then you're spending a lot of development time for a fraction of the market, maybe a smaller fraction, maybe a bigger fraction. So a lot of times they're deals, they'll give you marketing dollars or something like that to make it worth your while. Or maybe in some cases the install base is big enough to make it worth it. Or recently, NVIDIA's gotten really good at their DevRel has gotten really good at making the amount of added work very small. So it's just a simple slide in. But yeah, it was always this kind of the incentives were backwards, basically, or they were opposed for us and the IHVs, where they wanted it while it was still exclusive, and we wanted it when it was broad. So as far as the 30 APIs, I mean, we mostly ignored them, right? Like we mostly didn't use the graphics hardware when it was shitty. We would just use software rasterizers. In fact, I got hired at Westwood partially on the strength of my assembly programming skills, because they expected to use a software rasterizer for the game when it shipped. In the end, I ended up not writing a single line of assembly code at Westwood, but we had a license deal with a Finnish company, Hybrid, for their Surrender engine, which was this software rasterization engine. So software rasterization was pretty important for a while. And I think RAD, Game Tools, actually made some money on software rasterization years later than that. So when the graphics hardware isn't good, game developers just won't use it. When the APIs are too hard to use, game developers just won't use them.
Which brings to one of your lessons, essentially, that like building tools is the most impactful thing that you can do to any industry. And you guys both build tools on two levels, both in like your day jobs and the fact that you brought this knowledge to the industry. So wait, I want to hear. I wonder what it looks like when you guys decided to bring Naty on to the third edition of the real-time rendering book.
Oh, yeah, it was easy enough. It's like, at least my memory, my foggy memory is like, okay, this book is getting, longer each time. And, and sort of PBR and so on are the key topics. And it was just like, oh man, this is a lot of work. We could sit here and learn all this, I spoke, but hey, why don't we bring in somebody who really knows it? And so, you were able to come on in.
Yeah, I remember the way I remember it is I had heard on the grapevine that you guys were looking for a third author for the third edition, and so I walked up. I think it was to you, and pitched myself as I'm that third author. Hey, it seems to have worked. So
Yeah, right. Yeah, signed up for the pain.
This is a lot of questions now. So what did you have in your like how deep were you in the research at that point? Because you'd basically went down the path of PBR when Mark Cerny gave you permission.
Well, it wasn't permission; it was more like an order.
Sure. That was being polite. But where did you collect your material at that point? And because you showed the few articles that you found, and basically like the difference between where academia was at and where the entire industry was at. You set about just educating. What next?
Well, I mean, if you're asking where I would dig when I went on a digging expedition, I mean, by the time Mark made that request, he knew where I had he knew I had already done it in previous jobs, and even the terrain lighting, right? I started by just going and digging and trying to find material, and thank God for it. Wasn't even, I don't know if Google even existed then, but there were search engines, and there were papers that were online, and there were GBC talks, and there were things. So um, it's sort of the usual thing in terms of where I would look, but I would keep digging, basically, because a lot of times you look and you find the first layer and you're like, oh, that explains it. But a lot of times I'd be like, you know what, there's something here I still don't quite fully understand. And that's actually another unexplored benefit of giving talks or writing books or educating. you only really come to realize how much you understand something when you're trying to teach it. That's when all the holes in your knowledge suddenly become glaringly apparent. So I've learned a lot also from all the talks that I've given and the book chapters that I've written, because I would think, oh yeah, I know this subject top to bottom, and then I'd start thinking about how to teach it to someone else, and I realize, wait a minute, there's something here I really don't understand. And usually, when you find something you don't understand, that's an amazing opportunity to learn something that might be very useful.
Yeah, yeah, I agree. Or I think of it also as like, okay, I don't want to embarrass myself, so I better know the subject, or at least well enough to like, yeah, give a credible coverage. Yeah, so well, I had a question for you, which is sort of, I mean, we have that same kind of urge of like, well, it's really fun to sort of distill this down. You learn it yourself, which is awesome, and then hey, gee, maybe I can help people understand it. So I kind of hope everyone else has that, but they don't, I mean, which is fine. Some people like to, whatever, play golf. I don't know.
In my
But
case, it's not that altruistic. I mean, that someone is wrong on the internet hits home. I'm personally offended when people are doing things wrong. I must fix it.
That's really funny. I like that as a motivator, But yeah, no, I guess my question is, I know that I've seen ACM over the years. I3D certainly is one of them, where we're trying to, how do you engage the games population, game developer population? And certainly, Natasha's done it with her, course at SIGGRAPH year for what, 20 years now or something. I've lost track. But beyond that course, which gets like 6 speakers or something for the day, but how do you sort of get games, or is it just like, no, it's just luck of the draw? If the game person wants to do it, they find it out in their spare time, because there doesn't seem to be much motivation within gaming, or I don't know, films to a certain extent. I mean, occasionally say sketches or something.
Yeah, I think film historically has had more of a culture of sending
Yeah,
people to SIGGRAPH, but
yeah, yeah.
I mean, I think for any industry, you have your day job and you have
Right,
product,
right.
and none of this stuff contributes to that.
Uh-huh.
So there's a lot. If you're doing it, it's on your own time, and
Right.
sometimes your employer isn't happy with it or isn't supportive of it. I mean, there's certain employers, like if you're at Apple, basically forget about ever talking about anything ever.
Sure.
So some employers are more open to talking about things than others. But there are other employers that are like, oh yeah, you can talk about this technique for our game that just released. And there are some rare ones which doesn't make sense to me, which who are like, yeah, you can talk about this technique for a game that hasn't released yet. So I've seen that too. So it really depends on the company culture, I guess.
Yeah, yeah, no, it's just interesting to like, yeah, try to understand like that, sort of films, like you say, they sort of have more of an attachment with SIGGRAPH, and the games less so. Maybe it's because there's GDC and there used to be Game Developer Magazine, and I don't know,
I, I think it's changed a bit by now. I
Uh-huh.
think I think the difference is less stark than it used to be.
Yeah, oh yeah, yeah, no, I think so too. But anyway, it's just interesting to me that how sometimes you get this momentum of people wanting to do this, and sometimes it's like, it's not what I want to do.
Yeah, the fact that most people aren't into this stuff
Right.
actually should give you some humility, because if you're thinking, okay, I've read all the SIGGRAPH papers, I've read all the GDC talks, I now know what the state of the art is in,
Uh-huh.
let's say, the game industry, then the answer is probably you don't, because there's probably some really, really awesome stuff that nobody ever talks about.
Right, right, right. Yeah, yeah, that's the other trick. Because I mean, I know, um, in my own life, like helping with Journal of Computer Graphics Techniques, it's the, as far as I know, the only, well, I3D to a certain extent, and EGSR a little bit, and so on. But usually developers don't really have an outlet per se. I mean, Game Developer Magazine used to be, but it's gone.
Mm.
Gamma Sutra, that whole thing. But yeah, I mean, there's not a lot of outlets for people to say, "Hey, I've got this little idea. I want to." So I'm not sure what to do about that either. But yet another thing that's kind of limits. I think it's very much like researchers. Their life goal is to publish. Certain game developers not. And yeah, I don't know.
Yes, if you're a researcher, it's part of your job description, literally.
Right. Publisher perish.
I do want to double tap on that. I'm sorry, I'm using modern
Oh,
jargon for
good.
this. But so the overarching theme of recent years, but especially this year, now that we have agentic programming coming in and sweeping our jobs. And by the way, just for context, when I prompted Naty to do this talk, I told him students here are afraid of three things. One being that RTX simplified the entire pipeline. There's not much to do with the graphics research in general. And he's like, yeah, I guess that's right. And number two is, well, DLSS 5 is coming and eating all our lunch anyway, and we might not need to have lighting models to begin with. And number three, coding agents. We, like we might not have jobs. And Kayvon Fadalian yesterday was like, yeah, that's right. Um, and so, I'm trying to think about it in a different way. Now that you have the power as like, someone out of college, you have the power of a tech lead, just because you have tokens to use. What does exploration look like, and how would you go about making these experiments? For you guys, the way it started is you had to go through journals, and you had to go to libraries to do the digging, in order to find anything at all. And now there's two things that happen. You First of all, you can validate your math while you're on a coffee break, and secondly, you can ask people to call you on your bullshit. So how does that model look to you guys? Like now that you can explore so many things at the same time, and you can basically have a ray tracer written while you're in the bathroom, right?
Yeah, no, it's definitely Brave New World kind of stuff. I mean, yeah, my take is, I got to about a year and a half ago. Jensen Huang said, "Okay, everybody, we're all going to use AI," and so I actually had some time free to like actually look at all the AI stuff, and so I've been tracking for a year and a half, and like I sort of like look back on this year, and Claude Code came out in February, and I didn't try it till March, and I'm like, oh, I missed out on February because that thing is freaking amazing. Um, but I think there's obviously a lot of job fear and software like, oh my gosh, is career going to work and all that kind of stuff. I think for me, the hopeful signs or the takeaways for us is that if you're programming, part of your job, the job isn't like the code coming out of your fingers so much, and certainly now it's much less. But I think for most of us, at least, the skill that we've learned is breaking a large problem into smaller and smaller and smaller pieces to the point where I can write code to identify things, and that larger to smaller, smaller, smaller is still an incredibly valuable skill that a lot of people it's a skill. It's not something you're just like, oh, I know how to break this thing into this, all these little bits. So I think just from just a pure, worrying about jobs, that's one thing. The other thing that I take heart from is there is no limit to the amount of work there is in the world. It's not like, well, we've, as far as like maybe it is true for like grain or something. There's only so much how you want to harvest before you're like, I've had enough, thank you. That's plenty. But for work and software, it's like I take heart from things like, Google talks about like, oh, like 70% of our code is now AI generated. Well, from what I can tell, they're not laying off people because they have redundant people. They're like, we can do so much more. We can do all these other jobs. And the third thing is also just Amdahl's law, if that rings a bell with any of you hardware types, of yeah, that it's like you can totally compress that one code thing where the coding part, which is now maybe almost nothing as far as how much of your day is, but is your day most people's day I don't think is 9 to 5. I'm coding every minute of that day. You're doing code reviews. You're doing probably a lot of email communication with others, meetings, all those other kind of things. You're doing testing. You're doing all those things. Which, again, some of which can be automated. But I think all of that together is not just disappearing. Anyway, I'm going on and on. But
I didn't.
I'm trying to not feel too apocalyptic about this stuff. Admittedly, I'm biased at NVIDIA, but anyway,
Yes, please.
I'm off my pedestal.
Sorry, with the AI thinking and the jobs, I thought Natty had the perfect example in his slides. When you have a technical director or technical artist come to you and they tell you want to do something, if you just use AI, you may just type in, they want me to do X. But Natty's thinking allowed him to say, wait a minute, what are you actually trying to solve? And that type of thinking isn't going away.
Yeah. No, and the thing I really want to stress is that I thought was a great thing to see. I'm like, oh, thank you. Which is, yeah, read the darn articles because you find things on page 12 that are like, oh wait, I don't know about that. Like
Yeah,
if you just said, okay, oh, AI, give me a
there's
summary.
there's a trade-off. I know people who are able to get through a lot more articles than I can. Ask them, how do you do it? And they're like, oh, I have this method. I just read the abstract and I read the conclusions.
Yeah,
And I skip
yeah.
all the rest, and that is much more efficient. But sometimes you miss out on really good stuff.
Yeah, no, absolutely. I think, I mean, we, you know, you and I both have that joke about, computer graphics is the archaeology of math and all that stuff. But I think also it's getting to the point where computer graphics is the archaeology of computer graphics, like there's old papers or there's old ideas. I mean, in retirement, I actually want to go through some of the old SIGGRAPHs and just go, yeah, that was something that never really got pursued. Like maybe I could do something fun with that. So anyway.
I do feel like there's the other side of it, which is at least how I feel now that I still have a job, I guess, about like currently work, vibe research, which is this is awesome. I can, like I can ask so many questions. I can ask 5 questions, and I can go for lunch. And the boring parts, especially for a person with a little bit of of ADHD, you want to go through this, and you want to go through this quickly because you want to know what happens at the end. Um, Vibe research is perfect, right? So what I'm wondering now that we have these tools, um, I guess, what would you change in your methods if you had the next 15 years to dig in computer graphics and truly justify the fact that that you are researching? Like how would you scale yourself up?
Well, I mean, I'm probably one of the least qualified people in this room to comment on how to best use AI, but I've of course been using it like everyone else, and I've used it for a lot of personal research too. Like I'm trying to find. I've really gotten into cooking lately, so I'm trying to find the rare ingredient, or I'm trying to come up with a good, authentic recipe for something, and it's been very, very useful for that. And then for more professional type stuff, there's this. Omer mentioned this talk I did last year at SIGGRAPH about physically-based shading. And at the end of that talk, I promised that there's a director's cut coming, kind of an extended version of it, because that talk only had a 20-minute time slot, and there's so much more I wanted to talk about. So um, basically, Steve Hill, who was one of the organizers for that course, said, "Why don't you, do your full version and just we'll put it up on the course YouTube channel." And I've been working on it off and on ever since. And of course, it's scope crept a lot. It's probably close to 2 hours at this point. And we agreed, I believe, that we'll try to make sure it's ready by next SIGGRAPH. So, well, this SIGGRAPH, I guess, by August, which I think is doable. And one of the things I've been digging into a bit more is wave stuff, because that's something I felt I didn't cover well enough in the shorter talk. And while I was kind of looking into ways to explain thin film interference and looking for ways to show it, initially I would only use static images. And I've done a little bit of Python to generate diagrams for books and for talks. And there are Python libraries to generate animations too. But it just seemed like a lot of work to write a whole Python program to generate animation for like what would be 5 seconds of a talk. But vibe coding is excellent for that, because vibe coding, you don't care if when your code is written just as a one-off to generate media. You don't care if the code is shitty. You just care that the output is good. So the code doesn't have to be extensible or maintainable or any of that stuff.
Right.
And it's been really useful for that. And I've been able to do animations that would never have been practical for me otherwise. And then when I was working on that, I found that it's really interesting. My findings for working with ChatGPT is sometimes it can be dumb as a bag of rocks, and sometimes it astounds me with its insights. And like it would point out things like, oh, the physical assumptions you've made in this diagram, kind of the approximations you've made, they don't really reflect the underlying physical reality in the way you think they do. Like stuff like, it was mind blowing. Yeah. So, and then at some point while discussing and conversing with the AI, I kind of got an idea for what I think will prove to be a novel thin film interference rendering technique. So we'll see if it proves out, but I'm kind of working with ChatGPT as my research collaborator basically on that, and we'll see how that goes.
Same thing. So let's talk about distractions, because you guys have had like a long career in like rendering methods come and go, and you guys are first principles educators, and a lot of times you just have to say no, I don't believe in this, and I see this now, like let's say in like with Nerf or 3D Gaussian splatting, where some people say, yeah, well, that's going to die in 2 years and that's it. And like you already see people moving away from Gaussian splatting because that some people just consider it a dead end. I'm not saying this myself. I'm saying this is what I'm hearing. So I'm just wondering, if you can tell me about cases for at least people here who are starting their research career, understanding like what was a good time to resist a trend.
Resist a trend. Let's see.
I mean, the trend with I'm not sure if I hadn't retired, if I would have resisted the various types of AI rendering, or if I would have jumped on the bandwagon. Fortunately, I didn't have to make that decision. Right now, I can just be. I don't understand it, and I don't need to. It's fine. But I am a little skeptical about some of it. Definitely seems like people are ignoring some of the benefits of first principle rendering, but I honestly can't say. Like, it's quite possible in my mind that first principles rendering will be a completely dead discipline in 5 years. By the way, that won't decrease my desire to teach it. It'll just be like an interesting curiosity, right? Like, oh, here's how the math of optics works. And like, personally, I don't feel that will decrease my motivation if it becomes a completely irrelevant relic. But as far as teaching it, but it would definitely be an issue for me if that was my livelihood. So I guess I don't think that for me that's a good example of a trend to resist that I resisted. Like maybe I would have to look a bit further back. I mean, I can't really think of something like that. I'm sure there were. I'm sure there were.
Right, right. I almost don't want to say like, well, I never liked that routine, that area of rendering or something, because someone will say, no, that's a great area. I don't want to get in any fights. So, but there are things where you're like, well, is that really going to work out? Are you going to be able to animate that thing? Are you going to, and which are some of the questions like with Gaussians and so on, but are being addressed by the, research community, which I think is fantastic. Just like sort of talk about things like, okay, I've got this captured static model. What do I do with it? And people are being very clever about that. So that's like, oh, okay, that's hopeful. Because there are just things where I go, oh, that just looks too hard. But luckily, there are there are many of you out there that are not deterred, that are not just like, oh, forget it. I don't want, not like me, where it's like, oh, that looks like a lot of work, and it's like, no, like, there are people who actually, no, I'm going to do a lot of work and see if I can make this work. So yeah, it's hard to tell. Yeah.
I think if you've been doing this for a while, you learn to be a bit humble before making statements like that will never work out.
Yeah, exactly. Right. Yeah, that's always what, well, those are the people who get quoted,
Yeah, there's the
20 years
famous
later, we'll never have blah, blah,
yeah,
blah.
there's a famous story about the article on hidden surface removal methods. You're probably more familiar with it than I am, where there were like 10 methods discussed, and Z buffers were only mentioned at the end of, in a footnote as something that was wildly impractical and would
Right. They'll never catch on. Yeah, it was an appendix, and it was like they'll never catch on, or not that they'll never catch on, but it's like they use a profligate amount of memory, like up to a megabyte. That's crazy. No one will ever have that much, So yeah, it was just but at the time, I mean, it was true. You just didn't have that much memory. I mean, and that's what I love about this field is the fact that, some variable changes the amount of memory, or oh, suddenly we can compute this a lot faster, or just some variable along the, what's today's bottleneck? Oh, wait, that bottleneck just went away because we're now doing this. And it changes the field. It's not like there's first principles, there's, like definite physics that ain't going to change. But then there's like, oh, but wait, this just got 10 times faster, 100 times faster. Oh, I can suddenly do all this crazy stuff that I never thought of doing before. So
yeah, it's funny how well there's that. I forget who is supposed to have said it. It's difficult to predict, especially in the future. I think Yogi Berra.
Yeah, it's either Yogi Berra, Niels Bohr, or none of the. I mean, yeah, I've never been able to track down who actually said.
Yeah, it's interesting how some things. I mean, some things developed beyond our wildest dreams, but some things developed much less than our wildest dreams, right? Like it definitely seemed for a while that Moore's law would continue forever,
right?
And no one was expecting it to come to a screeching halt because of thermal issues,
right?
And things have had to adapt around that. Now things just have to become much more parallel.
Yep. Yeah. Parallelism is us. Yeah, that's definitely.
And there is a point about that is like I think worth discussing, because like it's been we, or at least younger programmers, grew up into a world where MMX was already old news. Well, MMX is essentially considered wasteful at the point that SSE was introduced. And then, we are all used to, like, if you're doing graphics, you're doing SIMT. And this is what you're working with. And, the developments in the past 10 years are showing that, well, SIMT might be good for certain things, but systolic arrays might be great for other things. And that has to change how programmers, well, think about things as basic as a game engine. And I'm wondering, if you see that there's a point in first principles today saying, wait, we have just been writing game loops and rendering loops in an entirely backwards way. If I have all this compute, if I can multiply things with as much cache as I have on a systolic array, I would do something entirely differently. I would love to hear if you've ever had these thoughts.
Well, I got a bit distracted by mentioning systolic arrays. Are they a thing now again?
TPUs, Google TPUs.
Oh,
true, true.
Are they actually systolic arrays?
At the center, there's systolic arrays, and then there's like vector units on the side.
Systolic arrays were going to be the next big thing back in like 1991. Designing a systolic array chip was actually my final project in my bachelor's degree. So it was, and then it didn't happen for very long. So I guess eventually it did happen.
Which goes to ask about the opposite of distractions. Did you see things that you thought, oh, if I just had more compute, if this weren't so slow right now, it would be a game changer, right? Like you can see that about coding agents nowadays, right? Like this, or at least I feel like I was born 20 years too early. If I came into this industry right now, I'd be like shocked at the amount of things I can do. So I'm just like wondering, what point were you thinking, oh, if this was a little faster, if we wait 5 years, this method could be awesome. If you had that point and thought, I'll keep this aside for a few years until I can actually work with it.
Well, I mean, for rendering, you can already do kind of whatever you want, but I guess one thing that would be really nice is if ray tracing was faster than this, right? The hardware accelerated ray tracing, I think, was a huge amount of promise. Like when RTR4 came out, it was like the big new thing. And, it is fast to an extent, but I think at some point people started realizing there's just fundamental bottlenecks of how the data is structured and everything. And because there was a while when it seemed like you could really, it would be nice if you could just use path tracing for everything, right? You didn't have to use rasterization hacks. I mean, that's basically what the film industry went through, right? They were doing a pile of hack upon hack upon hack upon hack. And then, when Marcus Fajardo with Arnold and others showed the way of, you can just have a dead simple path tracer that will do everything.
Right.
And maybe it'll run a little bit longer on some things, but you won't have to do all these hacks.
Right.
And, it would be really nice if games could do that. I already got to live in that world a little bit when I was working with Steve on Stagecraft. It's nice to work on effectively a game engine, but the min spec is, what did NVIDIA ship last week? So then you can say, forget about shadow maps. We'll implement only ray trace shadows. Forget about reflection maps. We'll implement only ray trace reflections. And that was really nice. But still, things were a bit noisy. And I remember dreaming about, could we just toss everything and go with pure, GPU accelerated path tracing? But I don't think RTX was quite fast enough for that. And it would be nice if it was, because it would just make life simpler.
Yeah, no, I know it is interesting to like sort of go, I've never had anything that's sort of set aside for 5 years because I'm a working stiff, and so they're saying, draw some lines. Okay, I'll draw some lines or whatever it is. So I didn't have like the ability to pick research. I'm much more of a developer kind of guy. But so my, I don't know, benchmark in my mind is let's see, so I'm out of Cornell. I got my first job, which, gee, what a coincidence. My advisor became my president, little, sort of startup that did a lot of consulting for Hewlett Packard for high-end rendering. And I just sort of for the heck of it, I put out a bunch of benchmarks, like a little benchmark programs. And the reason they were programs is because you can download a program in only a few bytes and then compile the program, and it generates, something with 7,000 spheres or whatever. Because sending 7,000 spheres, 4 floating points times 7,000, that's way too much data back in 1986. So anyway, so made these little programs, but you could crank them up, over time. If you wanted more spheres, go more spheres. So like one was Sphere Flake, in fact, which was like 7,000 odd spheres. And I remember putting out, I was amazed. I put this out on Usenet. This is pre-internet, just some code saying, here's all these things. The AT&T Pixel Machine people picked it up like, oh, we need databases. And I went to SIGGRAPH and someone's like, your picture's on the screen over there. I'm like, what? And like 3 weeks later, I posted it 3 weeks before SIGGRAPH, and they have this thing like running, an image in like, I forget, 40 seconds that took me on my, nice HP workstation a few hours to get. and it's all pure race traced. It's just a bunch of reflections, nothing too fancy. And so that was like amazing to me. Like, oh my gosh, they got it, 40 seconds. The next year they had it done to 20 seconds. And then nobody bought those machines because they were $300,000. And so you go, well, it's possible with enough, if you had like Turner Wood talks about ray tracing is embarrassingly parallel, right? You could, if you filled
if you fill the desert with
you filled a football field with crays and they all had a red, green, and blue light bulb, and you flew a blimp over, you got your real-time ray tracer right there back in the 80s. But anyway, so long and short is that I started at NVIDIA in 2018, and the first thing I do is I got my new card with ray tracing support, and I'm like, oh, how much can I crank this knob up? And it's like 40 million spheres, same database, but 40 million spheres at 50 frames per second. Okay, things have evolved a little bit. So, and that's what I love, is that you come back to some technique 10 years later, and it's like, oh yeah, real-time collision detection, sure, we can do that now, or just anything really. It's kind of great.
And there's one level of abstraction you can add to this. This reminded me one of my favorite talks. Mike Acton gave a talk at GDC, I think, a bunch of years ago. Not his famous CDD-Con talk where he disses C++. A talk where he essentially says what it is to be a tech lead, right? And he shows the practice of going through an Excel spreadsheet with numbers and trying to get optimization out of that. And that's interesting because what he's essentially doing is walking you through a painful skill, right? A skill that you need to learn with boredom and pain because you want to get the numbers down. And he's telling you, okay, you need to practice this like a muscle to get it right, right? And then so that thing now becomes super easy because AI, right? You can go and send an agent and do this dredge work. That means that anyone can come in and become like a pretty good tech lead as a junior. So if we have that, you have an audience of people in their beginning of the research career or the beginning of their game career. What is the painful skill that you should actually learn before you delegate it?
That's a good one. What do I know? Right.
Yeah, I mean, I guess I'm wondering to what extent you can be good at guiding an agent to write code if you haven't written code yourself or haven't got good at writing code yourself.
Right.
So you might want to not delegate it for a little bit. About other things, I mean, it's a good question.
Yeah, right. What's useful? Oh, well, this isn't a skill or anything, but it's a uh, check your ego at the door kind of thing, which is the ability to actually ask a question that you think might be a stupid question, but nonetheless you actually want to know the answer to, that you don't feel like you can look up later. I still remember actually going to an NVIDIA, like when I was at Autodesk, with some other people from Autodesk. We were in a little group, and there were a bunch of little groups, and they were teaching us all about shaders, about this new technology of shader programming, and da 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 da. And so we're all going through this course, which they'd never given before, and they understood the course, but we didn't. Like, we got at our table, we're like, I don't get it. Like, wait, there's some disconnect here. And so we asked the instructor, hey, what about this? Oh, yeah. This is how it works. I forget what the issue was, but it's something like, we went through all that, and we realized that there were, 8 other tables in the room, and none of them had asked that question. And we're like, we're pretty sure they're as clueless as we are. And, but we were, we had gotten over our ego of like saying, well, this is probably a dumb question, but I'm going to ask it. And I think that's really like an important skill, is to like, you know, yeah, don't ask really dumb questions, look it up, go do that. But yeah, to like get over the like, well, I should act like I know everything, get over the imposter syndrome, just try to be open and say, I don't know everything. Everybody here, in my group, you each have a skill that, you probably know more about things than I do. So, bring it on. I don't, anyway, I can't think of anything else as far as a specific skill though.
No, I mean, I can say don't delegate your research, but if you're careful in how you do it, you can have an agent. Well, I guess it's the difference between having an agent do research for you and having an agent do research with you. I think that's the difference really, because if you're just doing fire and forget it, you're not looking too deeply into the assumptions, you're not really learning anything. So that's a trap, I think.
Yeah, there's definitely a trap there. And also there's blind spots that those things have. I mean, like I've sometimes asked questions where I know what I think the answer should be, and it's like, wait, I missed that idea, but I missed that research. Well, okay, I'm not so sure about this now. So anyway,
Uh, did you ever find yourself having an agent call you on, like, okay, call you on your bullshit? Basically, like, fine. When you found something like, and you were expecting cacophony from the agent saying, "Oh, that's a great idea. You're absolutely right." And like, instead the agent runs the math and like, "Oh, well, that actually graphs much worse than you think," or something like that. Because this is what I try to do all the time. Like, I keep reminding myself that I'm actually not very smart. Like,
I have that. That's probably one of the things that impressed me the most about working with an agent is that I was working with it on this visualization of thin film interference, and you have to kind of decide how to map physical reality to the display on the screen, and you're making certain assumptions of, distance on screen means this thing, and the physical scene, and there was something I thought was consistent, and the agent called me out and said, no, it's not, and that was hugely valuable. So.
I wonder. I wonder if that becomes just the core skill to be able to pivot quickly. If you find that something is wrong, or like, maybe it depends on the person. You either pivot quickly or you stick to your beliefs. um,
Well, I
I
think
thought,
that's always been important, right? I don't think that's a new thing.
did you ever find yourself discovering something big because you needed to pivot quickly? I'll prompt you with this. I know that Michael Abrash tells a story all the time about, like, how um, John Carmack spent a week trying to figure out how to do light mapping on Quake. And then after a week of not sleeping, he figured out, like, the only logical method at the end. I'm wondering if that happened to you. If one of the things that you're hiding in your talk was a result of frustration.
Well, there are definitely times I needed to pivot and change things. There are times when I pivoted maybe harder than I should have, like in the case of, abandoning game development a bit too hard when I was a teenager. But I mean, there were cases where I learned a lot of useful things because of a choice I didn't make, right? Like when Mark asked me to investigate physically shading. But I can't think of a case where I had to pivot because of some external event and then I ended up learning. I guess you always learn when you have to pivot, but I'm
Yeah.
not sure what you mean.
Okay, so we are at the 2 hour mark.
perfect.
So I did one stupid mistake and did not bring the 3rd edition of real time rendering for you guys to sign. So, which means, like,
Fourth.
no, 4th would require Angelo as well, and I can't.
Oh, if you want to get the full set, then fourth requires, what is it,
Yeah,
5
yeah,
authors
yeah.
total? It's not
Six,
just Angelo.
6.
Yeah.
I can't make the USPS work that much. But so I want to say something cheesy, but it is important because we are at the 40th year, and, like, this is just how how we've been getting donations and everything. Like, all of this field is based on altruism, or at least the need to show off, and like, contribute knowledge to other people. And this starts from the fact that we have sponsors who knew that computer graphics knowledge does not come for free, and actually gave money, and we have people, like, spend all this time to um, pass their knowledge on to other people. And I wanted to thank you that you are doing all of this amazing job in passing the knowledge onwards, and essentially getting the new generation of first principles researchers out the door. So thank you so much for this.
Yeah, thanks. I do want to add one quick PS because I was like, oh yeah, I want to say this. You guys have done a fantastic job, by the way, on I3D. Honestly, I was originally like one of the general co-chairs for 2020. We were going to have it here, and then COVID, and but honestly, looking at what our plans were and what your plans are, you've done great. I mean, honestly, there's just been like a lot of great stuff. But I also wanted to say you were the guy that helped open the door, maybe with Stephen here or whoever, to actually have it here on this campus. So I really want to thank you for that, because that's something I know that I3D had been kind of knocking on the door here for a bunch of years, but you were employed here at the time. You were able to sort of get the gears rolling. So thank you, seriously, that was awesome.
I'm gonna open the stage for 2 questions from the audience, and then we can go for a break. So does anyone want to ask a question? I'm gonna go with the first one who came here.
Hello, my name is Hendrik. Thank you so much for your talk today. I think that it was incredibly insightful, and to have the entirety of your career's experience available to us is truly phenomenal. I wanted to focus on your narrative for your presentation, which is that you focused on lighting models for a large part of your career. My impression is that if you asked a physicist, they would say that the lighting equations that we have are complete. We understand all of the interactions that happen in light. And so computer graphics, from my perspective, is really just a sequence of, well, how do we approximate it so that it fits within an envelope of power and compute ability? And so my question is, in your pursuit of finding these better and better approximations for higher and higher quality graphics, when do you consider it to be complete? When we have enough compute that it actually fully simulates the physical light equations? Or is graphics rendering at one point complete when we're indistinguishable from reality in real time?
Well, things may be complete at one level, but they're definitely not complete on another. So there's this famous thing where chemistry is just applied physics and biology is just applied chemistry, etc. So we may understand all light interactions on level of waves, but as I pointed out, we still don't have a good theory of surface appearance. So because while you can, in theory, you could model the entire microgeometry and do a full wave simulation, and then you would get a complete answer. And the equations for that have been known since Maxwell. But you can't do that in practice. We need some statistical description at the scales that we care about. And we don't have an answer for that yet. So it's definitely not just compute that's missing. We are missing, miles are missing knowledge. And that's just one example.
Yes, thank you very much for the interesting talk. It was really fascinating. So you talked a lot about physics, and I'm also a big fan of physical-based rendering. At the same time, the more I learn about the brain, the more I'm trying to go away from this, because the brain does so much processing of the information, like edge enhancement, simultaneous contrast, sensor fusion, and what the brain actually sees is not what is there in reality, right? And there's this area of computational photography, which is utilizing this, which is actually changing the information which is perceived from the lens and processing it, and gives us an image which is much more powerful and informative of what actually could be physically presented on the film. And so I'm wondering, are you looking into this in your research? Like, do you take into account how the brain is processing visual information and use this to render it in a way that it's actually more effective for the observer? So maybe not physically realistic, but more informative.
There's a level at which that already exists. And I have some of my talks, if you look at my 2025 SIGGRAPH talk, I point out that physically based rendering is only half of the image generation problem. Because once you've done your fully physical simulation, you have the radiance values that are entering the camera lens. The problem is that what you have to show at the end is an image, let's say, on a TV. And the image on the TV, the frame buffer pixels are not the spectral radiance values that you have in the scene. And there's the entire scene to screen problem, right? There's the entire, I have physical radiance values. I have frame buffer values on a TV screen, on a movie projector, even, to printer that's printing a still image in a book. And, there's basically a whole body of knowledge around that. And there's a whole group of practitioners that's basically imaging science, color and imaging science. They have their own. I gave a keynote at this conference in 2013 where I was making the point that you need to look outside your field into neighboring fields. I made the point that I did some research into color science to understand the whole scene to screen transform better. And I realized there's this whole parallel universe, right? They have their own SIGGRAPH, it's called CIC, and they have their own luminaries and their own their own version of Jim Blinn and, their own Paul Heckbert. There's all these, and it's like this whole world running in parallel to ours. And they're really doing the other half, right, of image generation, which is, we do all the physics to get to the scene, but then you have to get scene to screen. So there's definitely a lot of perceptual stuff that works there, right? Because the fact that displays work at all with, you know, their tri-stimulus nature and the fact that they're so limited in dynamic range as compared to physical reality, the fact that it works at all is just us exploiting the shit out of the fact that the human visual system is so incredibly lossy, right? So there's definitely a big part of that already in existing practices that have been around for decades. Um, there's um, there's an image I use a lot, and I've done various versions of it over the years, where you see it's divided into two halves, and you see a person, let's say a person standing outside in a sunny meadow, and they're looking at the sunny meadow, and you see a thought bubble above their head, and you see the image of the sunny meadow in their head, and you see the same person sitting, let's say, in a living room, watching an image of the same sunny meadow on TV, and you see a thought bubble above their head. And the goal of imaging is to make those two thought bubbles the same, right? You're not trying to make the two images the same. That's impossible, but you want to make the two thought bubbles the same. And you can get, you know, with techniques that have been known for a century, you can get pretty close. Now, I think you're talking about something going beyond that, right? You're thinking about like cutting corners in ways that would make the image more appealing or more informative, less realistic.
So what I wonder is, do you need to bother with the real physics if you know what you create will then by the image processing guys be again changed in different ways? Maybe there's a shortcut to get the same effect without going over the step to create the real physics.
That's an interesting question. Like, I don't know how to do it differently, but if you could skip through that, that would be interesting.
Okay, thank you.
Guys, thank you very much.